Okay, cyberspace, we're back. Today what we're going to be going over is problem solving using proportions. And we just want to remind ourselves that proportions just are two ratios set equal to each other, so it looks like one fraction equaling another. And the steps we're going to take in order to do this is we're first going to identify what makes up the ratio in the problems. Then we're going to write the ratio in words. This is critical because it helps us do number 3, helps us set up the proportion correctly, and then once we have it set up, we can solve it. So let's look at some examples. So I'm going to look at, here's our first problem. So to make a special salad dressing, Wolfgang combined 7 fluid ounces oil with 4 ounces of vinegar. One day he needed a larger amount, so he used 8 fluid ounces of oil. How much vinegar did he need? So that's my question. How much vinegar did he need? So the first thing I need to do is I need to identify what makes up the ratio. Well, what things are being described here? Well, it looks like oil is 1. Right, so he's describing oil. Oh, there's repeats. And what else is being described? The vinegar is being described. So my ratio needs to be this mix of oil and vinegar. So here we go. Let's write that down. I'm going to write in words. So the ratio is going to be oil to vinegar. So now that I have this written down, the nice thing about that, it helps me set the problem. All proportion problems look like one fraction equaling another. So I notice there's always 1, 2, 3, 4 places to fill in, and conveniently I have 3 pieces of information here. So the oil is always going to go on top. So it tells me that there's 7 fluid ounces oil to 4 fluid ounces of vinegar. This is his recipe. And he wants to make this other amount, so he used a larger amount. He used 8 fluid ounces of oil. Well, since oil goes on top, that has to go here. And then, this is the thing I don't know. X and whatever variable you want to use. Hey, this looks like proportions like we did recently. So I'm going to solve this using cross product. 7 times, so I'm going to go that times that, so I'll have 7x equals 8 times 4 is 32. I just write this out. What's happening to the variable? It's being multiplied by 7, so I need to divide both sides by 7 to undo what's happening to the variable. And x is equal to this. Now let's see, looks like I'm going to have to do a little division on the side here. So how many 7s go into 32? Looks like I can get 4. 4 times 7 is 28. Do my subtraction. That's going to be 4. I'm going to have to put down a decimal and add a 0. How many 7s can I get out of 40? I can get 5. 7 times 5 is 35. And I'm going to want to get this answer rounded to the nearest tenth. So I'm going to have to go one more place value. 40 minus 35 is 5. Bring down a 0. How many 7s can I get out of 50? I can get 9. 9 times, 7. I take that back. I'm getting ahead of myself. 7 times 7 is 49. And that leaves me with 1. So 4 and 57 hundredths, what would that round to? That's to the nearest tenth would round to 4 and 6 tenths. So if he uses 8 ounces of oil, he's going to need 4 and 6 tenths ounces OZ of vinegar. So there's my solution. Tell you what, we won't do another one, but we will sort of look at a couple of others just to see what the ratios need to look like. So number 2, the ratio of height to width. So there's let me even tell you, the ratio. Height to width of a TV screen is 9 to 16. How high is a screen? That is 30 inches wide. So they give me the width. So in this problem, I can see that come on paper, start cooperating. So in this one here, number 2, it looks like I'm going to have my height to my width. And when I do that, I have my ratio is 9 to 6. And I'm given, I don't know what the height is, so that's my unknown for a screen that's 30 inches wide. And then I could use my cross multiply to do that. We'll stop here. I hope that helps.